Hello everyone, welcome to an exciting session of electronics. I hope all are doing good. In this session, we will learn something really interesting. Do you have any guess what it is? Okay, it's all about automatic street light circuit. Have you heard it before? So what is the application? Yes, it is used to turn on the light when it is dark. Before we are going to start our session, let's see how it's work. That's rather captivating. Okay, hold on. As you can see, this is our automatic street light circuit. Here, the LDR detect darkness as night mode. Now you can see the LED is turned off because the LDR detect it as light mode. So when we are going to create the LDR as dark mode, as you can see, our LED turned on. So when I just remove the hand, that means we are going to create again light mode by means of this LDR resistor. Then automatically our LED is going to turn off. Now we are excited to learn this session, right? Cool, I am also excited. Then why we are wasting our time? Let's start. In this session, we will make automatic street light circuit so that we learn the concept what is LDR, transistor and automatic street light circuit. I hope you have understood what we were going to learn in this session. Okay, now let's start the session by learning what is LDR. Do you know what is LDR? No issues, I am here with you. LDR stands for Light Dependent Resistor. It has an ability to detect both the light mode and dark mode. It works based on the photoconductivity principle. Here is our LDR sensor. We know that a resistor has two terminals but no polarity. Same here. LDR has two terminals but no polarity. Either we can connect the positive terminal or we can connect the negative terminal. When light falls on it, a resistance decreases. When there is no light, a resistance increases. I hope you have understood the concept of LDR. Okay, now let's discuss what is a transistor. Here is our transistor. Transistor is used to amplify or switch electronic signals and electric power. Basically, it acts as a switch. We can use transistor as on state or off state. Also, transistor has three terminals, that is collector, base and emitter. So, collector is the positive lead of the transistor. Base is used to activate the transistor and emitter is the negative lead. Here, as you can see, this is a symbolic representation of our transistor, because while we are creating our project, we are following a particular circuit diagram of automatic street light. In this session, we are using BC547 NPN transistor. So remember, transistor is basically used to act as a switch. It has three terminals, collector, base, emitter respectively. So how to identify by using this transistor? Very simple. Have a deep look into your transistor. Yes. It has a flat surface and a budged surface. So place the flat surface like this. Then the first terminal is the collector of our transistor and center one is the base and this one is the emitter of our transistor. So remember, collector is a positive lead, base is used to activate the transistor and emitter is the negative lead of our transistor. So you need to place the flat surface like this and then you can simply identify which is the collector, base and emitter terminal of our transistor. I hope you have understood the concept of LDR and transistor. Now let's build our circuit together. Please take your components kit and I will let you know which are the components required to build our automatic street light circuit. I hope you have all taken the electronic component kit and ready to build our circuit, right? Okay, now let's familiarize ourselves with the components required to build our automatic street light circuit. At first, this is our breadboard. We know that breadboard is a solderless board that is used to make temporary prototype. Am I right? Yes. In this session, we are going to build and test our automatic street light by means of this breadboard. So here is our 9-volt battery and the battery clip. So what is this? Exactly the resistor. So here we are using two number of resistor of different resistance value. So one is of 330 ohm and another one is of 100k. And here is our LED and this one is our BC547 transistor. We have already learned what is a transistor. Yes, this is our LDR and finally we are using one number of male to male jumper cable. I hope you have understood which are the components required to build our automatic street light circuit. Okay, before we are going to build our automatic street light circuit, let's have a look about breadboard, 9-volt battery, LED and resistor. So this is our breadboard. We know that breadboard can be easily divided into four basic parts. Which are they? A, B, C, D accordingly. Am I right? Yes. We also know that in A part and D part, the connections and configurations going on the same way. What about B and C? Exactly same. So here I am going to apply a positive voltage. Then what happened? Exactly, we know that in A part and D part connections go like horizontally. Then I can get the positive voltage from this entire point only up to 5 sessions. Am I right? Yes, because after the 5th session of this A part, which is not interconnected with the next one, that is 6th one. So if we are trying to get that positive from the another points after the 5th session, we need to connect it along with the first 5 session of our A part of breadboard. So simply we can say in A part and D part of our breadboard, connections go like horizontally. So what about the case of B part and C part? If I am going to apply positive voltage in the B part or C part of the breadboard, then I can only get that positive voltage from these points vertically downward. If I am going to apply the positive or negative or any other connection on the B part or C part of the breadboard, then I can get only that connection from that points vertically downward. So that is the property of B part and C part of our breadboard. I hope you have understood the concept of breadboard. Okay, so what about this 9-volt battery? Yes, we know that 9-volt battery is the electric source here because we are going to power our circuit by means of this 9-volt battery. It stores electrical energy. Okay, tell me what's the purpose of resistor? Exactly, it is used to control the flow of electric current. We know that resistor has two terminals but no polarity. Either we can connect the positive terminal or we can connect the negative terminal. So how we identify the resistance of a resistor? Exactly, you are right. As you can see, there are different color strips in our resistor. So these are basically called bands. So these bands determine the value of a particular resistor. So finally our LED. So tell me what's the full form of LED? Good, light emitting diode. So what are the application? Night lighting, art lighting, etc. So basically it has two terminals. Yes, it has polarity. So the larger one is the positive and the smaller one is the negative. Also we know one important thing. You got it, good. We know that LED work only if the positive should be connected along with the positive of the battery and the negative should be connected along with the negative of the battery. I hope you have understood the concept of breadboard, 9-volt battery, resistor and LED. Okay, now let's start to build our circuit. But wait, how to connect these things? That's our LED, transistor, LDR properly in our breadboard to get a better output. You got it, exactly. We need to follow a particular circuit diagram, am I right? Yes. So here is our circuit diagram for automatic street light. Do you know what is a circuit diagram? Very simple. Circuit diagram is basically the graphical representation of an electrical circuit using symbols. As you can see, each and every component in our automatic street light are representing user specific symbol. So this one is our symbol for 9-volt battery and here we are using two different resistors, right? Yes. So R1 indicating 330 ohm resistor and R2 indicating 100 kilo ohm resistor. And this one is our symbol of LED and here is our BC547 transistor symbol. We also know that it has 3 terminals and here is our symbol of LDR. Now have a deep look into it. The connection starting from the positive of the 9-volt battery. We know that the larger line indicating the positive of the battery and the smaller one indicating the negative of the battery. So we can start from the positive of the 9-volt battery. And then that positive is connected along with the two different resistors. That means the positive of 9-volt battery, we need to connect it along with the 330 ohm resistor. At the same time, we need to connect the 100 kilo ohm resistor. This 330 ohm resistor is connected along with the positive of our LED. We know that LED has two terminals and one is positive, another one is negative. So larger one is a positive terminal and the smaller one is a negative terminal. So this 330 ohm resistor is connected along with the positive of our LED. And what about the negative? Exactly, the negative is connected along with the collector terminal. Because as you can see, this one is our collector and here is the base of the transistor and this one is our emitter. And the negative lead of the LED is connected along with the collector terminal of the transistor. And what about the another resistor, that is 100K resistor? Yes, it is connected along with the base terminal of our transistor. LDR is connected along with the base terminal and the emitter terminal. So we need to close the circuit by means of connecting negative of the battery along with the emitter terminal of the transistor, because we know that collector is a positive lead, base is used to activate the transistor and emitter is the negative lead of the transistor. So that's why we just connected the negative terminal of the battery along with the negative of our transistor, that is emitter terminal, right? Yes. I hope you have understood what is circuit diagram and circuit diagram of our automatic street light. Okay, then we are following this circuit diagram to build our automatic street light to get a proper output. Let's see how it is. Okay, the first step to build our automatic street light, we need to connect the 9-volt battery along with the battery clips. So here two wires coming out from our 9-volt battery, right? Yes. So red is a positive and black is a negative. Because for better understanding of circuit, we are representing red as positive and black as negative. Okay, so now your turn. You need to also connect the battery clip along with the 9-volt battery. I hope you have completed. Okay, now our next step is to connect the positive along the A part of our breadboard. We know that according to our circuit diagram, the connection starting from the positive of the battery, then that positive is connected along to two different resistors. Am I right? So here I am going to connect the positive of my battery along with the A part section of the breadboard. Then also we know that when we connected a positive point along with the A part of breadboard, then this entire point up to 5 section will act as positive. So now your turn. You can also connect the positive starting from the 9-volt battery to the A part of the breadboard. Now our next step is to connect the 330 ohm resistor. So the color code will be go like orange, orange, brown and gold. So this is our 330 ohm resistor. So here I am going to connect the 330 ohm resistor along with the positive, because don't you remember about our circuit diagram? Yes, exactly, the positive is connected along with the two different resistors. So here I am going to connect the 330 ohm resistor along with the positive of the battery. That is, we know that in A part of our session, this every point up to 5 session will act as positive. So here I am going to connect my 330 ohm resistor along with the positive of the battery. I hope you have completed the connection of 330 ohm resistor along with the positive of our battery. Okay, so what's the next step? Exactly, we need to connect the positive of LED along with the 330 ohm resistor. So we know that the larger one is the positive and the smaller one is the negative for LED. So here is my positive, and we know that while we are connecting this resistor along with the positive of the battery, then now this B part of breadboard, this entire point will act as positive. Am I right? Yes. Here I am going to connect the larger leg of the positive along with the positive point of the resistor on the B part of our breadboard like this. Now your turn. You can also select an LED from your components kit and connect the positive of LED along with the positive of battery through the resistor. I hope you have completed. Now our next step, we are going to connect the BC547 transistor along with the negative of the LED. We know that we need to connect the collector terminal of our transistor along with the negative of the LED. So here right now each and every point will act as LED's negative, and we know that how to identify the collector terminal of our transistor. So place the flat surface of our transistor like this, and this one is our collector, center one is the base, and this one is our emitter. So I am going to connect the collector terminal along with the negative of our LED like this. So here we know that this one is our negative of LED, and I am going to connect the collector terminal of our transistor along with the negative of the LED like this. I hope you have completed the connection of transistor collector terminal along with the negative of LED. Okay, so now we are going to connect the LDR along with the base and emitter terminal of our transistor. So here is our LDR. We know that LDR has two terminals but no polarity. So according to our circuit diagram, we need to connect the one terminal of our LDR along with the emitter terminal, and the another one we need to connect the base terminal. So here as you can see, this is our emitter and this is our base terminal. So we know that this every point is right now base point and this point is emitter point, because that is a basic structure of our B part and C part of our breadboard. In B part and C part, the connections go like vertically downward. So here I am going to connect my one terminal along the base terminal and the another one is on the emitter terminal like this. So now it's perfectly fixed because here is my one terminal and I just connected it along with the base terminal of our transistor, and the another terminal of our LDR is connected along with the emitter terminal of our LDR. So what about yours? Okay, so take your time but ensure you are connecting the one terminal of LDR along with the base of transistor and the remaining one is connected along with the emitter of transistor. I hope you have completed the connection of LDR along with the base and emitter terminal of transistor. Okay, finally we are there, only few more steps. The next step, we need to connect the 100K resistor along with the base terminal of our transistor, because we know that from the positive of the battery two resistors are connected, that is 330 ohm resistor and this one, that is 100K resistor. So here we just connected our 330 resistor. Also we need to take the 100K connection from the positive of the battery, because we know that this each and every point will act as positive and I can get the positive simply from these point. So here I am going to connect my 100K resistor along with the one point of our breadboard, and then that I am going to connect it along with the base terminal of our transistor like this. Now as you can see, I just connected my 100K resistor along with the base terminal of our transistor, because we know that according to breadboard in the B part, this each and every point will act as base and this one is our emitter. So we can simply connect the 100K resistor along with the positive, that is A part of our breadboard, and the another terminal to the base terminal of our transistor like this. So now your turn. Take your 100K resistor and connect the one terminal along with the positive part of our breadboard and the another terminal to the base part of our transistor. I hope you have completed the connection of 100K resistor. Okay, so the final step, we are going to connect the negative of the battery, because we know that black representing negative of the battery, right? Yes. So here I am going to connect the negative of the battery along with the A part of our breadboard beside the positive of our 9-volt battery. So now your turn. You can also connect the negative of your battery along with the A part of our breadboard beside our positive section. I hope you have completed. Okay, so here is our final step. So we need to close this circuit. As you can see, we are not yet connected the negative of our battery along with the emitter, because according to transistor terminal connection, emitter is a negative one, right? Yes. So here we are going to close this circuit by means of connecting the negative of battery along with the negative terminal, that is the emitter terminal of our transistor, by using this male to male jumper cable. So here as you can see, this each and every point will act as negative, because that is the basic structure of our breadboard. And I am going to take a negative from the breadboard point, and here is a negative right now. We know that this another terminal will act as negative, and I am going to connect the negative terminal along with the emitter terminal of our transistor like this. Yes, here it is. So finally I just completed my automatic street light circuit by means of connecting the negative of our battery along with the negative, that is the emitter terminal of our transistor. So what about yours? Okay, so take your time but ensure you are connecting it properly. I hope you have completed the connection. Okay, then as you can see, our LED is still turned off. So what we need to do? Exactly, here I am going to creating a dark mode. We already know that our LDR has a property to detect both light mode and dark mode. Right now here LED turned off. That means LDR is detecting light mode. When we are going to create a dark mode by hiding our LDR like this, then as you can see, our LED turn on automatically. Now you are super excited. So this is all about our automatic street light. That means LDR going to detect light mode, then the LED turn off, and the LDR going to detect dark mode, then what happened? LED automatically turn on. So what about yours? I believe you also got the output. Okay, I can see the acceleration from your faces. So remember, you need to follow the circuit diagram to get a proper output. So this is all about our automatic streetlight circuit. Before we are going to wind up our session, let's summarize what we learned in this session. At first, we learned about LDR, right? Okay, so tell me, what is the full form of LDR? Light Dependent Resistor. We also know that LDR works on the photoconductivity principle. So what is the superpower of our LDR? Yes, it can detect both light mode and dark mode. When light falls on it, resistance decreased, and when there is no light, resistance increased. As same as the resistor, it has two terminals but no polarity. So what about the transistor? Exactly, transistor is used to amplify or switch electronic signals. Simply, we can say it is used in electronic switches to turn on and off. So what about the three terminals of our transistor? Exactly, it has three terminals, that is collector, base, emitter. Also here we are using BC547 transistor, and which is a positive lead of our transistor? Yes, collector is a positive lead and base is used to activate the transistor, and emitter is the negative lead of our transistor. Also we learned about breadboard, battery, resistor and LED. Am I right? Yes. So how our automatic streetlight will work? Exactly, we need to follow a particular circuit diagram to build this. Am I right? Yes. So it starts from the positive of the battery, and then that positive is connected along with the two different resistors, that is 330 ohm resistor and 100k resistor, and the 330 ohm resistor is connected along with the positive of the LED, and the remaining LED negative is connected along with the collector terminal of our transistor. Also the LDR is connected along with the base terminal and the emitter terminal. Finally, we are going to close this circuit by means of connecting the emitter terminal along with the negative of the battery, because we know that emitter is the negative lead of our transistor. According to the working of our automatic street light, right now LDR detect light mode, that is our LED is turned off. When it detect dark mode like this, then what happened? Yes, LDR detect it as dark mode and automatically our LED turn on. Automatic streetlight circuit building using electronics components kit is interesting, but very sorry to say it's time to wind up our session. I hope you all enjoyed. Keep this energy. Have a nice day. Thank you.